Well, good morning and welcome back to our final day. It's a very exciting sessions on both what's coming in the future with AI application in healthcare medicine, as well as what are some considerations for us to move forward. So it's very exciting speakers as in the past few days. It's just been mind-blowing in terms of the level of interest and passion that we feel from this meeting, even more so than last year. As you know, we registered over close to 550 people, but more importantly, 550 very passionate people about this cause from all areas. And I think we just had an early morning meeting of clinicians who are interested in pushing this agenda forward. And I was expecting 5 to 10 people because it was a 7 o'clock breakfast meeting and we had about 40 people. So I think you continue to inspire us, and we'll continue to work hard to make all of this happen year after year and really make impact in medicine, which is what we strive for. So in terms of what's coming, looks like we're going international next year based on the demand. Most likely the second half of next year will end up in London, which is, as you know, another epicenter for AI application in healthcare. And also based on the level of interest and the growth in Asia, we'll probably end up in China in November. And of course, every year we'll come back to California for this meeting as well. So you'll have plenty of opportunities to catch up with AI Med starting next year. There was a lot of discussion this morning about having a continuing forum based on the level of interest. So we'll set up in addition to the website, which will be a resource for you. By the way, we'll have all the slides and all the talks videotaped and ready to go probably by early January. So you'll just have to relax during the holidays and not look at this stuff. Although you have access to the ebook, I'm kind of worried. But no, it's amazing the level of curiosity and interest. So we'll have an ongoing video or internet presence. We will probably deconstruct all the questions that we've seen throughout the meeting and add it to last year's, and we'll actually have discussion streams and blogs from those questions. So we're going to invite the speakers to be engaged with you throughout the year. And we'll also be in production for some a video series on sort of the hot topics. I'm not talking about the 45 minutes in length. I'm talking about very short videos. So you'll have a lot of opportunities. And again, in the process of evolving the ebook into a textbook, have a major publisher interested in the book concept as well as a book series focusing on the subspecialties and applications, for instance, for radiology. There'll be a separate small book on radiology and AI applications. So there are plenty of educational tools coming. Again, this was not a good picture, but this was the first night of the first day of the meeting, and was just so inspired by all of you. This was taken, I think, about 6:30, and there was still very few seats left, even at that time of the meeting. We rarely see that at any meeting, this level of interest and passion. So thank you for that. Again, thanks to Tata and Crosschecks and Santen and Systems Oncology, some of the really major sponsors and startups that were just a very key part of the meeting, as well as our media partners throughout the meeting. So we thought it would be interesting. Let me see if okay. So what we did last year, as you recall, if you were here last year, was to have a word cloud based on all the traffic on the forum, on the platform. And you can see the keywords in terms of machine learning, modeling, and learning. And this is a similar cloud from this year. I'm not sure how CAN came up first. I haven't previewed this word cloud, but it's interesting the word CAN came up a lot. maybe it's in the question form. Can we do this? Can we do that? Okay. Okay, some takeaways for me from yesterday. I take a lot of notes, and one was seems to be some agreement that AGI, or artificial general intelligence, so the really what I call the smart AI, will be here in our lifetime and probably sooner than some people think, so probably within 10 years. We need to have not just deep learning, which is obviously the hot topic right now, but also understanding in addition to deep learning. The good news for doctors that don't want to learn coding is that AI may not be needed for coding in 3 to 5 years, so if you can wait that long. And we need to, I think Crystal really drove this point home yesterday, that we need to be aware of cognitive homogeneity. And judging from the doctors that came to the breakfast meeting, I think we have tremendous cognitive diversity, so which is good. And lastly, I think it's important to think about introducing liberal arts and human skills back into data science. So those were some of the major takeaways from yesterday. And again, today we're just talking about, after this keynote session, we're going to talk about emerging applications as well as key issues from some of the best people dealing with these areas this morning. And just a quick few things on innovations in AI in medicine. This is literally came from a napkin from Jeff Hinton talking about the concept of capsule network and deep learning, and find it very encouraging that he's going back to understanding brain science or neuroscience to get inspiration for deep learning. So the whole concept of capsule network is based on capsules in the brain when we have a shortcut to do a task or remember something. So even though you might think there's a dichotomy between deep learning and cognitive computing, as we talked about, is actually there's some convergence of the two areas. And I think another thing that's coming is blockchain technology. I don't know what it is this morning, but it seems to be really going crazy. So be aware of the hype. So you know, I'd like to leave you with some C words that are key for the theme of the day. One is cognitive. I think it's important to remember that deep learning is sort of the methodology of the day, but it may not be the only one in the future. And I think what Gary and others have talked about also is the concept of potentially a third wave, which is going to focus on the more sort of biological way of doing AI, which is dealing with cognitive architectures. So the not so good news here is I think things are going to get even more complicated with AI, but the gratifying thing is going to be, I think, even more applicable for biomedicine. I think I look at the AI methodologies as sort of a full-fledged orchestra. And right now we have, for sure, the deep learning crowd is the sort of the violinists. I play the violin, so I can relate to that. And we have the cognitive side now becoming part of the orchestra, more mainstream anyway. So they're sort of the violas and the cellos. But we have lots of room in the orchestra for all of you. So we also can think of in a way, the data scientists as really outstanding musicians, but they need questions to answer. So in a way, that's sort of like composers. The clinicians, even if you don't play an instrument, you can certainly be a composer and or a conductor. And the other C word is collaborative, which is the theme of the meeting. So this was a really friendly handshake at the AlphaGo event after AlphaGo from Google beat the human champion Lee Sedol. And what wasn't really publicized was that even though the human champion lost, I think four matches to one, what was fascinating to me was, first of all, that the AlphaGo software made an incredible move on the for those of you who are really super nerdy, was the 37th move of the second game that I think a computer for the first time did something that was totally unexpected. did not learn from a human in terms of making a move. So maybe a little surreal moment that it was actually being creative or maybe even thinking. But what impressed me more was that in game 4, that Lee Sedol took a similar strategy that he had seen with the computer and made a very audacious move that won him that and the only game that he won was game 4. So again, that to me is very symbolic of man-machine learning together for the future, which is something we try to espouse here. So this is me getting inspired under the Sistine Chapel. You're not supposed to really take a picture in the Sistine Chapel, so I'm not going to post this on the internet for sure. We have some Italians here, so please don't report me. But what inspired me was the fingers coming together when God created Adam. Now, I know if you're a data scientist, you think you're on the right side of that diagram, but or if you're a seasoned clinician, but it's not important that who you are in that picture. It's important that we kind of collaborate. And one remarkable scene I saw in Rome was, if you go to Rome, you'll probably see this at twilight, these amazing swarms of birds or flocks of birds making these amazing natural patterns. And I don't know if you've ever seen this, but if you happen to be in Rome, this is worth waiting for. And that reminds me that not only should we collaborate, but we really should take advantage of swarm intelligence, which is a hot topic in artificial intelligence now. So all of us working together is going to be something absolutely amazing to help children. This is my 2-year-old who has a chronic medical condition, Olivia. That's where a lot of the passion to do this, I'm sure, comes from, is she really could use more medical knowledge and intelligence in the future. So it comes down to, even though I think intellectually this is very gratifying and very cool, it comes down to applying this to help all of us. We're all going to be patient someday, so this helps every single human on the planet. On the other hand, as attractive as some of the applications are, there's a lot of relatively mundane work. This is my 2 girls doing the mundane task of brushing their teeth every morning, and I have to coerce them every morning. But let's not forget that a lot of the things in healthcare and medicine that are not necessarily decision support or medical imaging need a lot of help from AI. And I mean some of the logistical issues with workflows and how the healthcare system actually works is actually going to be and should be an important part of the future. So with that, want to do a quick sort of interview with Emma and her parents that I've invited here on stage, who've really impressed me with their level of passion to not just help their daughter, but help other children with heart disease and how they manage to do that at home. And I'm just going to give a mic to the mom and the spokesperson, but the dad is extremely good at his version of data science. And those of you who've seen my talk from Exponential Medicine remember that famous graph that I got a lot of comments on. Mr. Molly actually put together and plotted Emma's pulse oximetry readings for a couple of months and really was instrumental in helping me make a decision about timing of surgery. So tell us briefly your story and what you feel are roadblocks to having the healthcare system take care of Emma.
Okay. Hi, I'm Patrice. This is Emma. She's 5. She was born with hypoplastic left heart syndrome, and it seems like Chalk has taken very good care of us since the beginning, almost too good of care of us because you feel very alone at home. Here you are bringing this child, and she had her first open heart surgery at 6 days, and it was a couple months before we made it home from the hospital, and you're under constant monitoring by doctors and nurses and all of the technology, and they're watching those monitors monitors all the time, and you learn what those monitors are and how important they are. And then you're sent home because things are better, and it's overwhelming. You go from this environment of 24 hours a day, seeing the doctors and the nurses read all this information and how important it is, whether it's our oxygen or blood pressure. Monitors are just constantly beeping, and then you go home and you have nothing. We were told that we could, look at her color to see if her oxygen's looking good, or read her lips or her fingernails if they were bluish. And for a parent, that's scary and overwhelming. But in April, Dr. Chang allowed us to use an at-home monitoring system, and we took it home after her third open heart surgery, which was difficult, but she made it home, and the changes of being able to monitor things that made us nervous or scared or concerned were great. We've decided to purchase a at-home monitoring system, a pulse ox like Dr. Chang had, and take medicine into our own hands. And my husband's graphs came out of that, trying to figure out if it was close to the next surgery. But the technology that Dr. Chang has sent us home with has kind of give us a little bit of peace and a sigh of relief, at least that we know what's going on and we can contact him if we're scared or concerned or nervous.
So what's I think the next wave of AI application is going to be bring that sort of level of care to the home, so that the parents or family members, in the case of adult patients, are much more comfortable taking care of them at home. And it's one thing to hand them a monitor, but it's a totally other thing to have some sort of interpretation of the data, right? Because you can't collect the data and not make sense out of the data. So, Mr. Moon, tell us what inspired you to make that graph that so many people are talking about. I don't have it here with me, but it's a graph of 2 months worth of pulse ox readings, and it was very impressive, not just in terms of the level of detail, but just how important it was for data to help make a decision.
Well, one of the things that we were taking a look at was trying to time her next surgery, and we were taking spot readings of when we would be in your office once every other week. And if she had a rough morning or she was upset, it was giving these false low readings. And you had said, well, I think it's time. And I said, but this isn't her normal. Like her normal at home, she was reading higher. So that's when we got the idea, let's just graph the whole thing. And that way you weren't taking a snapshot of where she was at, you could get a feeling of where she was truly at in her normal living conditions at home. One thing about kids and Emma going to doctor's office is they become apprehensive about it. They have negative experiences, and they don't act the same way, or they get stuck in a ton of traffic, or they're hooked up to monitors and they're just uncomfortable. And we were seeing that it wasn't, for her, it wasn't an overall good picture, and it was leading possibly to false or maybe not entirely accurate decisions being made by her team. So
I think it's important for all of us that, the doctors in the hospitals, which is a lot of the discussion the past few days, only literally 0.0205% of the patient's time. So if they're outpatients, we need to really start focusing on outpatient care as how they are at home. So, great. So we talked about application of AI, so you have a lot of data, but that data at home, even with the monitoring system, wasn't always interpreted right away. So what do you think as parents would be helpful? Would some sort of interpretation of the data help you? Because you like to empower yourselves with as much information as possible. What, in an ideal world situation at home, what would you like to see in the future?
Me too.
It's something that will actually say she's like a sort of green, amber, red system, or what would a parent like to see?
I think in the beginning, you're learning so much, or we're teaching ourselves, not that you guys don't give us that information, but we're really teaching ourselves what is a safe zone, what is a concern zone. And that took a while for us to decide, because when you go in once a week, twice a week, or once a month, it's, she looks good, she's good, and you go home. But we know there's so many things that you and the rest of her team are keeping an eye on, and we'd like to be made aware of that. So if we are nervous, I mean, I don't know necessarily a color system, but something along those lines of we're getting close to being concerned about this.
Okay.
Being able to see the data right away. I mean, we do have the at-home monitoring system, but that's something that's, I know,
Yeah.
still being refined
Right.
as to getting that data to us, because we do want to see the trends.
Yeah.
And even though we have that at our fingertips, we're not seeing where she was last week compared to where she is this week. If, things are going downhill and it's time for another surgery, not necessarily in her case, but other families'
Yeah.
case, it would be nice to know, because we need the mental and physical preparation to get
Yeah.
ready for that. It's a lot of work on our ends,
Yeah.
too. So some
No,
sort of data.
It's amazing how much parents actually do want to know. And one of the things that we learned together was I just naturally assumed that the data that they were gathering was actually available for them. And in fact, it wasn't. It was only available for the clinician. So something I think we all need to learn together is, empower the patients with their own data as much as possible, because they actually want to learn. And I bet you compliance and understanding of disease is going to improve tremendously if you know that, if you're empowered to understand and have the data. So having the patients have the data and be willing to share the data was a huge discussion point yesterday. Would you be willing to share Emma's data, for instance, like all of her data, even at home? Share it with other parents and other doctors?
Yes.
Yeah.
I think we're open to sharing just because it helps everybody else if we had been in the same boat. I also just want to say, we've only been doing this for 5 years, but I feel like it's changed so much from when we first had her. When they sent us home, it was such a mindset, at least we felt it was, that don't worry about it, we've got it taken care of, you don't really need to know this, you don't need to know that. But I think seeing all of this, it's nice to know that you do want the parents involved and you do want us to be a part of all of this, which is great.
Any parting words from a dad data scientist? So we talked about doctor data scientist. This is a dad data scientist.
Well, I agree with Patrice in that the more.
But you always say that.
I know I've gotten better at that, but the more that we know, the more we're prepared for it. It's one thing to go in for these surgeries, but it's another thing to prepare for them. You have to prepare the family for them. So there's a lot of different layers that go into it. It's just not showing up the day of the surgery. And if you can see that trend and you can pinpoint where that's going to be, and when you start to get into that range where we're really going to start to narrow down the window for that next surgery or heart cath or whatever it is,
Yeah.
then we can kind of prepare for it.
Yeah.
Whereas we've had a few times where we're not prepared at all, and
Yeah.
we just had to do stuff.
Yeah.
And those are harder to deal with.
Yeah.
So the more that the family's prepared, it makes the whole thing not easy by any means,
Right.
but less difficult.
Yeah, no, it was tremendously helpful that the parents are so and like to empower themselves and contribute to the decision. That was and it turned out to be the best decision, I think, timing-wise. So, Emma, do you have any words to tell us? Any wise words? Do you want the microphone?
What do you think of the technology? She gets to use it, she does it at home, right?
Yeah. What do you think of the technology?
What do you think of the machine at home?
Do you like the machine at home?
Yes.
Okay, can we give them a round of applause? Thank you. Okay. Thank you. Do you want to stay or do you want to go back to the table? You can make that choice.
Table.
She wants to go back to the table. Okay. Okay, thank you. All right, bye, sweetie. Okay. Thank you. So that was, again, we had a really great breakfast meeting this morning with the doctors, and some of the points were, let's get the patients even more involved with owning their data and sharing the data with them. So I think that was just testament to that. So we're going to start off with Jack from Google.
telling us what we're expecting in the future.
Sure. Thank you very much. Thank you for inviting me here. I'm actually very distracted right now by Emma. She's extraordinarily cute, so forgive me if I forget my entire speech. So I want to talk specifically about two applications that we've been working on at Google around healthcare. And one of them, many of you might have heard about already. This is a research that we started working on around 2 years ago that we published last year around diabetic retinopathy. Specifically, this was what many folks have referred to in last year's meeting as well as this year's meeting about trying to build a neural network to try and grade retinal images. So in many patients with diabetes, their back of the eye starts showing sign of clinical deterioration when they have very uncontrolled diabetes or even mild uncontrolled diabetes over long term. So the deteriorations actually eventually lead to blindness. So one of the things that is helpful, one of the things that are recommended is to do annual screenings of these images, what are called retinal images, to try to see if you can see evidence of damage and then try to adjust their medication so that they can forestall blindness if possible. So roughly, ophthalmologists will look at these images in one of 5 ways. Basically, it's a spectrum of whether someone has damage in the back of the eye towards someone having very severe damage at the back of the eye. So ranging from having no diabetic retinopathy all the way to what's called proliferative diabetic retinopathy. So one of the advances that happened was we realized that we can actually take neural networks that were trained from other applications. So in this case, Google has spent a lot of time working on images coming from YouTube, coming from the web, and we train a lot of these neural networks. Anthony and many folks in this meeting have talked a lot about neural networks in general, but we built this neural network that was very good at reading images in general, reading images from the web, and we wondered how good it would be if we took that network and actually just applied it to medical images. In this case, we basically took the exact same network that was trained on web images and put in a lot of retinal images, and basically just asked the neural network to additionally train on relatively few medical images compared to images from the web, and try to see if it can just distinguish these 5 categories that I mentioned earlier, as well as some housekeeping items. And it turns out that the networks can actually do this very, very well. So this was the results that was done last year, where basically the neural networks can actually distinguish these 5 categories almost as well as ophthalmologists and almost as well as retinal specialists. So this was the, I think, major paper that came out last year that really started pushing a lot of different folks from industry as well as academia to try to use this neural network in many different applications. And since then, folks have used this convolutional neural network in radiology and dermatology and many other spaces. And it's shown that in general, it works pretty well in medical imaging, period. So in the last year, the groups have really started to push on 2 other things that many folks have been talking about in these meetings. So one is the neural networks are very good at trying to classify images. So what is an image actually should be labeled as, but is there a way to explain what the neural networks are actually focusing on? So there was a lot of work from us, from many other folks in academia, in trying to modify the neural networks to try to actually give indications of what they're actually focusing on. So this is an example, obviously not on medical imaging, but of work going on in ImageNet, where we started building neural networks that can actually give essentially a heat map or using colors to give information to folks about where the neural networks are focusing on when it issues out a label. So you can see in this case, 2 different types of dogs were identified by the neural network, and we can actually zoom in on where the neural network was actually focusing on. And this allows us both to tell folks where the model was focusing on, as well as to give folks a suggestion of physiological phenomenons when we say why a certain image was classified as a certain disease. So another type of investigation the Google group started working on was actually try and see predictions that we could make that maybe humans cannot see. So there are lots of suggestions that the back of the eye actually contains vasculature, contains blood vessels, that physicians have always assumed that you should be able to see other types of research findings. So for example, you might be able to tell things like cardiovascular risk, so risk of heart attacks and risk of strokes and etc. So one of the first studies that we did that we recently published in the last few months was, can you, for example, just looking at the back of the eye, predict gender? So it's obviously not something that you need to look at the back of the eye to tell, but that was more an exercise to see, can the neural networks pick up things that the humans cannot actually pick up? So in this case, it turned out that the models can actually tell gender with a fairly high accuracy. So then we tried to do, can we do these predictions on things like cardiovascular risk, stroke risk? Can we predict what might happen in 5 years to the patient? Will they have a heart attack or not? And it turns out that looking at the back of the eye of an image taken today, these models can also see what a 5-year risk would be in 5 years, what a risk can be in 5 years, which is itself very, very interesting. So we're starting to look at neural networks and see whether they can make predictions into the future on things that humans really right now cannot read off the back of the eye. Another piece of work that the Google groups are spending a lot of time on is something called variant calling, which is actually a piece of technology around genetics. So it turns out that genetic sequencing is a very, very difficult thing to do, and it's also, of course, very critical to biology in general. So the way we've really started to do next generation sequencing, basically from the start of the Human Genome Project, was a big invention that allowed us to really cut up the genomic sequences and sequence very short snippets of genetic genes instead of doing long sequences. But the issue is of really cutting it up to short snippets is that you then, of course, have to reattach it all. So if you take a big piece of painting and you blow it up into a puzzle, the issue then is you have, of course, have to reassemble the puzzle. And one of the things that's really important in genetics is not only reassembling a standard puzzle, but figuring out which puzzle pieces changed, because you're trying to figure out what genetic differences have actually arose in that specific person or animal to give you insight into what diseases or what genetics might be contributing to a person's disease. So the hard part is both, in this case, aligning a lot of the sequences, as well as then, while in the process of aligning these sequences, you're trying to figure out which puzzle pieces might actually not be shaped correctly, and where that misshapen thing might be. So this is a huge amount of work. This is the work that actually enabled a lot of the Human Genome Project that was originally not done at Google, of course. But we decided to see whether deep learning can actually help in doing this project. So what we did was we basically labeled, so DNA sequences are basically one of 4 characters, and you can basically assign a different color to each of these different characters. And we first do a very preliminary alignment, and then we basically just convert it to a picture. Given that deep learning works very well in pictures, we basically converted all the candidate sequences into pictures, as you can see on the left, and basically asked deep learning to try to pick up the mutations off of the images. So it turns out we also just use inception, the same thing that the imaging, the neural network that was learned off of web imaging. And we basically just threw all these images, whether it's mutations, whether it's true alignments, whether it's false variants, into it and asked the network to learn. And it turns out that that model also works really well. And in fact, it won many of the challenges that came out in the last 2 years or so. And we actually, as of, I think, a few weeks ago, just open sourced all of these tools, both in our cloud as well as outright the codes that were available. So what's next? I think there's a lot of work that needs to be done for further validate some of these tools, as well as the need to build a lot of the infrastructure that's needed to get more data, as well as the infrastructure to actually implement a lot of this in clinical medicine. So I'll skip ahead a little bit. So there's a lot of work that needs to happen to actually get a lot of the data. We're right now spending a lot of work just collecting the data. So Google Cloud has actually built a lot of tools to make some of this possible. These are various tools that you might have heard about on the first day when the first Googler talked about both storing and processing this data, just so that you can enable the research and enable deployment of these tools. And of course, we've started to deploy that in some hospitals, as well as open source many of our APIs for neural networks, as well as learning that you can actually use now if you were to look at Google Cloud. And this is an example of folks at Stanford actually doing this work in dermatology, basically using some of those tools. So thank you very much, and now I will hand it over
Thank
to
you,
Leo.
Jack.
Hello again. This is a bit of a departure from all the other talks that you've heard. As technology enthusiasts, we are tempted to think that technology will transform healthcare. But there are other elements that are just as important. And for the next 10 minutes, I'm going to focus on an innovation that I think we all need for our community to really advance, and that is on collaboration. Before that, I'm just going to give an overview again of our activities. People have heard of the Mimic database and the Philips database. These are both open access ICU databases. I've talked about a course that we teach at MIT where we bring together the data scientists and the clinicians. There's a book that is ready to be downloaded for free if you are interested in secondary use of electronic health records. And we have these events that we hold all over the world where our idea here is really to interface the data scientists and the clinicians together. This is from China just a month ago. Anthony, Jack, and I were there. And as you could see here, we live streamed the event to the rest of China, and we had about close to 120,000 people viewing our talks and our panel discussions. We talked about this datathon model, and we published that in Science, Translational Medicine. I also wanted to say that what we don't want to do is to further the divide between rich and poor countries. We feel that poor countries are even more likely to benefit from leveraging the value of health data. So we have a project called SANA. And here with this particular project, we partner with our colleagues in low and middle income countries and assist them with developing and adopting and scaling a digital health infrastructure. The idea here is to convert them from a paper-based health information system to one that is digital-based and one that is machine-ready for machine learning. We have a course that would talked about how to build this informatics platform, and we also launched the course on edX. It's a massive open online course. It will be open again in the spring of 2018, and there is a book that you could download for free if you are taking the course. And we have several projects from Brazil to India to Uganda where the focus really is on global health informatics. How do we teach them in terms of laying down the groundwork for a digital health infrastructure? And with that, I'm going to focus on collaboration as an innovation. And I'm going to quote Albert Einstein to kick off this topic. So we can't solve problems by using the same kind of thinking we used when we created them. So somehow, I hate the cliche, but we need to start thinking outside the box. And the idea now is maybe we need to train a new generation of leaders. And I wanted to start out by saying that the greatest accomplishments and the most disruptive innovations are seldom the work of a single individual. When Anthony showed Sistine Chapel, the person that comes to mind is Michelangelo. But in fact, there were 16 painters who actually painted the Sistine Chapel. It's not one person. And yet we still think of achievements in terms of the great man or the great woman instead of the great group. One of my favorite sayings is that none of us is as smart as all of us. People may have heard of Project Aristotle. It's this project at Google where a team looked at several teams at Google to see what made them work well with each other. And these are some of their findings. Apart from studying the teams, they also reviewed half a century of academic studies looking at how teams work. And it turns out that it wasn't the who that mattered in terms of what made teams work effectively. Two teams may have nearly identical makeups with overlapping memberships, but radically different levels of effectiveness. So what is the key ingredient? The key ingredient is what they call as the group norms. These are traditions, behavioral standards, and unwritten rules that govern how a team functions. And there are two very important group norms. The first is that there has to be equality in distribution of conversational turn-taking. And the other important element was there's a high average social sensitivity of teams that work very effectively. Some of you may be familiar with reading the mind in the eyes test. A lot of companies are already starting to use this to look at emotional intelligence. Are people able to see what the other person is feeling just by looking into their faces? So psychological safety is a very important concept. There are two key components, conversational turn-taking and empathy. Interpersonal trust and mutual respect in which people are comfortable being themselves is really the key element of psychological safety. And it turns out too that these are the same unwritten rules that we turn to in order to form a bond. The human bonds matter more at work than anywhere else. These are my list of recipe for innovation. As we go around the world trying to create a culture of innovation and entrepreneurship, these are some of our pointers. How do you recreate the MIT ecosystem at universities in other countries? So it's very important that you have a cross-disciplinary melting pot. There is an interface for people with different backgrounds. And there also has to be involvement of domain experts who understand the issues deeply. And very important, and it turns out that this is probably a crucial element, is a strong academia-industry partnership. We see that here during this conference. There's a lot of support from industry who are interested in advancing artificial intelligence in medicine. There has to be focus on learning and research. You can't just be doing things. You have to demonstrate how it is impacting outcomes. You have to try to identify best practices because we cannot really advance forward if we're not learning as we go through this journey. And a rich global network is very important. So I'm delighted to hear about AI Med in Europe, AI Med in Asia. That is an opportunity for us to really bring together some of our partners who have been in this area for the last couple of years. And finally, the most important element, you have to establish a great groups mentality. We need to influence not only how people work, but how they work together. And I'm going to end with a quote from Luciano di Crescenzi. He's an Italian. We are each of us angels with only one wing, and we can only fly by embracing one another. And I made a mistake. There's one more quote that I want to end with, and this is from a paper that we just published from this past summer. For a true data revolution to occur in healthcare, we must become better at sharing and integrating data. Greater emphasis on collaboration outside the traditional multidisciplinary realm and into the engineering, mathematical, and computer sciences will help us to achieve this. And with that, I'm going to end my presentation. Follow us on social media. Thanks.
Thank you, Leo. And then I wanted to bring on Jules Sherman, who is going to give us yet another different way of looking at application of AI as we go into the future. Jules?
Well, thank you for having me here today. My name is Jules Sherman. I'm an entrepreneur. I'm a researcher and product designer at Stanford Medical School, and I'm a lecturer at Stanford's D School. At the medical school, I focus on designing products for improving safety in labor and delivery. And at the D School, for the past 5 years, all of my classes have focused on maternal and infant health care. And if you want to learn more about my classes, you can go to www.redesignhealthcare.org. So at the D School, we teach human-centered design. And human-centered design can be explained through 5 distinct phases. The first phase is the empathy or understanding phase, where we're trying to really understand our users. And once we gather a lot of data about our users, we start to define the problems, and we prioritize those problems. And then we pick one of those problems and ideate around it. We come up with all kinds of solutions that might help our user in the form of products, systems, or services. And then we prototype those ideas rapidly, and we test them with our users. And we do this process over and over again in an iterative fashion. And it looks very linear here, but it's actually a very non-linear process. So a designer need finds in order to understand a user's experience by learning about their lives. So we do this in 3 different ways. We immerse ourselves in their environment, we interview them, and we shadow them in their day-to-day life at work or at home. And we do this because one of the reasons we do this is because we're trying to understand our users' core values. Many times, the people that I'm researching can't really tell me what those core values are. It's up to me, the designer, to really draw that out through the research that I do. And another reason we spend a lot of time in the understanding phase is to try to uncover the gaps between what people say they're doing versus what they're actually doing. And we create user maps as a tool to help us synthesize all of this data that we're collecting. We might pull out really interesting quotes that we've heard in our interviews. We might pull out different bits of video or pictures or drawings that we've created while we have been out in the field. And organizing this data through this process, we can then perhaps infer what our users might be thinking and what they might be feeling. And then we're ready to create a point of view about this research. And we do this through a problem statement or a need statement. And we have a formula for creating these statements, and it helps drive our design. It's really important to create this point of view at the beginning of the design process. So we start with our user with empathetic language, and we then tell in the statement what that user needs. And then at the end, we tell why that user needs that thing, whatever it is. And that why is really the nugget. It's the golden nugget. It's the insight. And the insight is so important because it's really often connected to an emotional element of why that person needs whatever it is we think they need. And in order to make new products or systems or services stick with people, it needs to answer to an emotional need. And I use this print from Escher to describe what it feels like as a designer to go through this research process. It's truly a metamorphosis for me every time I go embark on a new research project. I might be going in with preconceived notions about what I'm going to find, the problems I might see, but in fact, it's always so much more nuanced and complex, especially in the medical world, which I'm very much in right now. And I always exit that research phase truly transformed, thinking about things in a different way. So AI has brought some new tools to designers, and one is generative design tools. And this is a very interesting thing to use for people like me, but it's more towards the end of the design phase. It's in the prototyping and testing phase. So it still takes somebody like me to decide what the problem is that we want to solve, and somebody to input criteria into the machine so the machine can spit out different variations on the design. So I think this is really cool. But something I've been thinking about a lot, especially during this amazing conference, is what kind of AI tools could be used collaboratively, kind of dynamically with the designer at the beginning of the design process. So in like the empathy, understanding, and problem definition phase, how could AI tools be implemented in my process as I do my research on users? And I leave you with this slide that I found from John Morley and Associates. It's an interesting visual comparing and contrasting design thinking methodology with machine learning. And I think it's a really interesting comparison. I would argue that the analyze and synthesize modules in machine learning would be combined in the problem definition space in design thinking. Because the empathy and understanding phase, I think, stands alone. It's a high-touch, human-centered activity that I believe can only be done by people. Thank you.
So, thank you, Jules. So as I was putting this last day keynote session together, I thought, one good way to kind of wrap it all up after a lot of, discussion about the machine aspects is to come back to the human aspect. And I intentionally didn't, ask our keynote speakers to speak on specific topics, and I just let them kind of freeform the session. And in a nice way, it kind of came back to humans, right? The human elements and the application of AI in medicine. Jack talked about needing humans to collaborate and get more data. Leo talks about collaboration as an innovation, and Jules now just talked about design thinking, letting humans decide what they want the machines to do. So there's a question here about to Jack about how do we understand how the algorithm was able to predict the male versus female based on the retinal image. Technically, how does that happen?
Yeah, so I think that's a very good question. So we actually use very similar heat map technology on the male versus female neural networks, and we actually show this to retinal specialists and show this to physicians who are trained in physiology. So there should be a paper coming out either at some point next year where we essentially have a lot of physicians trying to hypothesize why the neural networks were looking at certain locations to try to figure out an image was either tagged as male or female. It's, I think, a very interesting application of neural networks where we're starting to use the findings from the AI to try to suggest hypotheses for humans to try to understand physiology better.
It's a good question about how do we really integrate the insights and the knowledge that you just spoke about into the workflow.
I'll let Leo speak to that.
So I think when you ask that question, I think you're too late. The patients and the physicians have to be involved with the design process from the very start. And I get that all the time. People would pitch an idea, can you help me sell this to the clinicians? And to me, it's almost like doing a post-mortem.
Right.
The patient is dead, you cannot revive. They have to be there from the very start. They need to be involved with identifying the problem and really designing the solution to the problem. And the same way with the patient. So trying to bring them in and trying to sell it to them and trying to integrate it to their workflow at the end of the product is the wrong approach. And this is a funny story because I tell them that selling something to the clinician, and it's an engineer or data scientist selling that, to me, I feel insulted when an engineer tells me that this is the way you should practice medicine. Like, who are you to tell me how to improve the way I care for my patient? This is like me telling you this is how you should build your bridge. You will never listen to a doctor. So somehow the partnership has to really commence at the start of the project.
Yeah, I always tell my students that you're doing the design right if you're the catalyst and your users are actually the designers.
Mic up. Jules, I think you were a little bit intrigued when I asked you to come to an AI meeting as a design thinker, because I was already thinking that's actually one of the most important aspects of application of AI into medicine and healthcare. Are you still intrigued, or do you think actually that's something that we all need to understand?
I do think it's something we all need to understand across so many fields, and it all starts with people. So if we can understand each other better, then the things around us are going to serve us better.
Yeah, we did a quick audience survey, and very, very small number of people are sort of going to the other person's domain. Very few clinicians are exploring the possibilities for the data scientists as a group, and for the data scientists, very few are wandering into the hospital or clinics. So I think some of the doctors are saying, well, they don't know how to code, they don't know how to get into the AI business. I think one thing you can do is find a way to welcome a data scientist or a computer scientist into your clinic or into your hospital and just get them oriented better on the real needs of the medical care system. And there's another question for, let's see, human-centered learning. How do we compare human-centered learning and machine learning to develop empathetic AI like Molly? So do you see the other way around too, that machines can learn to be empathetic? No one wants to answer that question.
No, I mean,
no human wants to answer that question. So can you teach machine or AI? And I think there is some discussion about that already. Recently, to be a little bit more empathetic. I think one of the avatars actually is now more popular than the patient's own physicians because it was more empathetic. So can you really teach a machine to be empathetic, you think?
I think you can. There are labs at different universities working on that right now. I know there is a lab at MIT working on a robot that is learning empathy much like a baby learns empathy through facial recognition, different emotions. I do think that, like yesterday, what Crystal was talking about, how there's different levels of cognition and context can be very complex, that there's several layers to understanding what's going on, and I'm not sure that machines are at that level yet.
So I guess it depends on what you mean by empathy. So in the last year or so, there's been a lot of work to create chatbots that are actually very, very good at mental health. So in China, there's a company called DXY that actually basically give clinical advice to patients who are asking about certain symptoms and what they should be doing next. And they're widely viewed as much more effective than actually physicians. In the US, there are companies like Seven Bridges. Tom Insel, who recently left Verily Google, is also working on a number of initiatives like MindStrong, where you have computers who I think don't quite understand what empathy means, but is able to learn how good physicians generally respond to requests. And Seven Bridges is a automated system that talks to folks about mental health issues. And there's two findings I think that's very interesting. So one is folks are actually much more open to sharing their mental health issues to computers than to humans because they don't feel like they're being judged in any way. So the conversation turned out to be much more honest. And second, they actually turned out to respond better because they view the system as being completely non-partial. So Seven Bridges had, I think at this point, tens of millions of conversations in the bank, and they have had enormous success actually talking folks from committing suicide, self-harm, and things like that.
I think that's particularly relevant in this day and age. I always say we're over-connected and under-communicating. There's the perception that having LinkedIn and all of these communications that we're improving human relationships when I think, in fact, we're actually not, and maybe even being counterproductive. So I'm so glad that you each picked an area that happened to come back to the human element of what we need to do for AI. It was just a quick mention about the movie Her. I think most of you probably seen that movie about a lonely writer falls in love with the empathetic AI, which I think is happening based on what I'm reading. At a dinner last night for the faculty, people were talking about people actually falling in love with Alexa and relying on Alexa like it's another human element in the family. So it's amazing dynamics. So the comment about doctors needing more training and lean and design thinking and empathy, but I think all of us, including the data scientists, need more training, especially if we're dealing with healthcare and medicine. So what do you think about just a quick question to finish up the session. Mental health is such an important area for us right now. Everything seems to be on the rise, particularly suicide among teenagers. Do you think there is hope that technology and AI particularly can mitigate that tremendous societal burden? Jack, you're nodding like you want to say yes.
So I'm very excited about what's happening in mental health. So I have heard about various companies who are building chatbots. I've seen some of these comments are hilarious. I have seen
iWife.
Crisis Text Line, if any of you have heard about it, is a startup that actually does mental health interventions for teenagers. So teenagers many times are very uncomfortable talking to anyone else, so they text their crisis to this line, and there's an AI actually that sits behind this bot that's basically figures out how likely this this teenager is actually in trouble and uses it to triage the conversations to different types of humans who are better at certain things or worse at certain things, and then actually then track. I think there was a point here that humans do need to intervene, and then actually basically sends off the queries onto the police department, the fire department, to make sure that in cases where there's a very high risk of suicide ideation or actual planning, that they get the help that they need, and then they actually do longitudinal tracking. So I think in mental health in particular, there's a huge model of both liberating a lot of this interaction from having patients have to go to a hospital, so doing it in an outpatient manner, and then using AI to really facilitate these interactions with very, very limited actual trained professionals right now available. I don't know.
All right, so with that, we'll wrap the morning session. Any last words from our amazing parents? No? Emma? She's got her earphones on. So, you're not paying attention, Emma. No, we're just kidding with you. So thank you very much. We'll have a rapid transition into our first session this morning. Thank you.